Garfield is being accused of being lazy, and he said, I happen to be conducting a scientific experiment. Thank you very much. Lazy, lazy. No, I'm testing the first law of physics, which says that bodies at rest tend to stay at rest. In other words, he's going back to sleep. So he's half right, even though this is not exactly what Newton meant by that. So we're talking today about forces and motion. More specifically, we're going to be talking about Newton's laws of motion. How many laws are there? Do you know? Let's see who was paying attention on departmental day. How many laws of motion did Newton come up with?
3.
Yes, 3. All right, and we're going to be talking about the first one today, Newton's first law. So what we want to do today, we want to define what inertia is. We want to be able to state Newton's first law, and we want to discuss the effects of unbalanced forces on an object's motion. So we've already started to talk about forces, just in general, types of forces. So some of that knowledge is going to be useful in today's lesson as well. So let's define inertia. Inertia refers to the tendency of an object to resist changes in its current state of motion. So, like Garfield was telling his owner, if I'm at rest, I want to stay at rest. My current state of motion is at rest, so I want to stay at rest. If I'm moving, then I want to keep moving. Okay? That's inertia. Inertia is the resistance to change. Where do we see this a lot? Think about and when you're watching a 100-meter dash. When the runners get to the finish line, do they stop automatically?
No.
It takes them a little while, so because they're going so fast already, they may want to slow down, but practically it's going to take them a couple more strides over the finish line. Okay. Newton's first law says that an object at rest will remain at rest, and an object in motion will remain in motion until an unbalanced force acts on it. Okay? Unbalanced. What is an unbalanced force? So all that simply means is that we have unmatched force in the vertical or horizontal direction. And wherever the force is unbalanced, whichever direction the force is unbalanced, motion occurs in that direction. Okay? So we have two cases of tug of war here. We look at our picture. So if you recall, when we were talking about the force that causes a rope to stay taut, what's the name of that force, by the way? The T. All right, I'll tell you, it's tension. Okay, do you remember that word? Okay, good. All right, so the more force exerted on each side of the rope, we're going to have motion if the forces are unbalanced. Okay, so if we look at the first scenario, we have 300 newtons being exerted by this side and 300 newtons being exerted by the opposite side. They're both pulling equally as hard in opposite directions. So when the forces are the same, we get still or steady speed. Okay? So either it won't move or it will keep moving at the same speed it was moving before the force was exerted on it. Okay? So same or same force, we get still or steady speed. Okay? So just like tug of war, they're both pulling equally as hard, so neither team is going to fall over. They're just going to stay there in the same spot that they are. But what if one person on this side decides to give it a little bit more gusto and they decide to pull a little bit harder? Well, now we see that the other team, they're starting to lunge forward because now the forces are unbalanced. This side is pulling harder, and so this team is going to move in the direction of the bigger force. So when forces are mismatched, we get motion. Okay? So when forces are the same, we get still or steady speed. When they're mismatched, we get motion. So what about A? For A, are we going to have still or steady speed or motion for A?
I think, I don't know.
All right, let's see if you're right, Kiara. But first, let's decide what's happening with B. So look at the forces. We're trying to figure out if the forces are the same in the horizontal and vertical direction, then we're going to have still and steady speed. But if we have a force that does not have a matching partner, then we're going to have motion.
But B is unbalanced.
So what does that mean? What are we going to have?
Motion?
All right, let's see if you're correct. So first thing I did, I crossed out my matching pairs. So 25, 25, matching, matching. Those are the same. 20, 20, same. So we have same all around. So that's definitely going to be still or steady speed. This one, we can only cross out the vertical forces, but the horizontal forces don't match. Okay? So if you said A is same, is still or steady speed, and B is motion, you are correct. Very good. Let's try this one. So for those of you just joining, we're looking at balanced and unbalanced forces, okay? If the forces are the same in the horizontal and vertical direction, then we get still or steady speed. And if they are mismatched, either in the vertical or horizontal direction, then we get motion in the direction of the bigger force. Try this one. C and D. Still or steady or motion?
C, I think it's
What the rest are you thinking?
I said no.
All right. Let's see if you're correct. Okay. Don't worry if you're just joining. I'm recording so you can go back and look at it. Just let me know that you missed some and you want the recording, and you can have it by tomorrow. All right, so if you said C was motion, you are correct. Good job. Okay. And D is still or steady speed. We're looking for mismatched forces. That tells us that the object is going to be moving. And if we have the same forces, then the object is going to have still or steady speed. Okay. New word, the unmatched force. So that's the one that's mismatched or left over. It's called the resultant force. Okay. For C, the resultant force is 20 newtons. Okay. So after we cancel out all of the matching pairs, what's left over is our resultant force. Okay. For D, we have no resultant force, or the resultant force is 0. Okay. And when the resultant force is 0, then that means we have still or steady speed. Okay. Let's look at this question. What is the resultant force of each object? It is 10:25. I'm going to give you until 10:27 to answer this.
Let me answer.